As you can see in this movie clip, we have the software running off the laptop to run the system. The handheld probe is easily attached to a stand for ease of use, and we also have a spinning stand option where averaging over an area is important. We can also now have a look at the portable Raman spectrometer. Put these together and you have the TranSpec Raman system. In this clip we are going to test TranSpec with a 6% melanine cyanurate concentration in nylon. As in the previous screenshots, we have designed a solution to do this and can now use this for routine analysis. The sample is placed under the probe and we run through the method. The first step is to optimize the setup. This then feeds into the next step to decide how long the scan should take to maximize the quality of the data. The probe is collecting the Raman scattering from the laser's interaction with the material. And different materials will have varying intensities and thus scan times will vary. Most polymeric materials can scan in tens of seconds. This type of routine analysis requires very little training, and further batch measurements can be carried out much more rapidly as the system has already optimized. Here we can see the final step before the results are shown. TranSpec has successfully measured the sample as 6% melanine cyanurate. The previous section shows how some FR concentration measurements would be carried out, but TranSpec is not restricted to concentration measurements. It can also achieve high molecular discrimination, meaning that complex mixtures and detailed analysis can be carried out and compounds identified. This could be used for the plastics industry to the pharmaceutical industry. This high quality of data also allows correlations to properties of interest to be identified, opening up possibilities for multiple property measurement in one scan. An example of application for high molecular discrimination is the area of brominated flame retardant analysis, as it has historically been a very tricky analysis to do, as the compounds are very similar and the concentration levels can be low. Alternative analysis such as XRF can only give elemental information, for example bromine concentration, but not identification of the FR. And infrared-based techniques do not have the spectral range to pick out the brominated bonds. TranSpec's high molecular discrimination means that it can be used to identify a wide range of compounds accurately. In this example, concentrations of alumina trihydrate and alumina trihydroxide in EVA give varying LOI scores. This can be correlated by TranSpec to the spectral data and models built to predict LOI. Again, this is a unique feature of TranSpec. Gnosis has already worked closely with a number of major additive producers and compounders, and thus has an experience in a vast range of thermoplastics, flame retardants and additives that are constantly being added to. We have also started to predict properties like LOI and UL scores. In other areas of research we have also predicted aging and lifetimes, melt flow indices and many other properties using the TranSpec's concept. Gnosis wants to work closely with its clients so they can get the maximum advantage from a tailored setup. This is why we like to offer sample trialing so that the database can be built with your specific materials, and this will then help to feed our plans for the future. We are currently looking for ways to easily measure black materials, develop the probes for inline measurement, as well as constantly improving the software and adding to our database on our expertise. If you have a specific material of interest that you would like to test with TranSpec, then we do offer a 5-day proving service. We require 5 to 6 known sample materials to build a model, typically a concentration range of an additive. We then build and calibrate TranSpec to this, and then test it on a supplied mystery sample, and we report this back to you so that you can build confidence in TranSpec with your materials. We do charge for this service to help cover some of our costs. To summarise, I hope this presentation has given an understanding of the concept of turning data to knowledge that drives TranSpec. By using cutting-edge Raman spectrometers, high-resolution spectral information from a compact unit can be rapidly achieved. We then use all of this data with our software to build information-rich databases, and then correlate this to the properties of interest, given a unique and powerful non-destructive analytical tool. This can be used to qualify and quantify multiple additive measurements, but also allow property predictions and trends to be investigated through the correlations with the spectral information. The speed at which this analysis can be taken offers significant time and cost savings. To see how TranSpec can work with your materials, we are offering sample trials where you can send materials to be tested to give you the confidence in these methods. We are constantly developing TranSpec to meet the needs of the plastics industry, so if you have a specific problems, we are here to work closely with you. Thank you for listening. Now is your opportunity to ask any questions you may have.